Imagine this. You are dreaming that you are sprinting away from a giant bear. Your heart is pounding, you feel stressed, you feel blood pumping to your face, your legs, and then suddenly you trip over a rock onto the ground. But then you realize you are actually out of your bed and are running straight into the wall. Or maybe you are dreaming that you are in a boxing match and are throwing punches towards Mayweather, just to wake up and find out that you have actually punched your lamp across the room. Usually, it is common for children and young adults to be told they were sleepwalking late at night or talking and holding conversations in their sleep. Some will wake up with mysterious bruises and soreness in their body from trying to fight something that is not real. However, when these people wake up, they're unaware of why these things have happened and how they have occurred. This phenomenon is not just tossing and turning. This is REM sleep behavior disorder, or RBD, a condition where the brain's normal paralysis during dreaming breaks down and the body starts physically acting out dreams. To understand why this happens, we need to zoom in not just to the brain, but deep into the neuroanatomy that underlies sleep. So let's start with REM sleep, or rapid eye movement sleep. This is the stage where most vivid, story-like dreaming happens. During REM sleep, your brain becomes highly active, almost awake level active. The visual cortex, the motor cortex, the limbic system, and all association areas are going to be firing intensely. Your eyes will dart around, your emotional circuits fire intensely, but your body is supposed to stay completely still. Your entire skeletal motor system is shut down. It is not weak, it is not tired, but rather it has become paralyzed in a sense. REM sleep is a regular part of our daily sleep cycle, in which the EEG of an awake individual is displaying similar high brain activity in the form of beta waves to an individual in REM sleep, while the skeletal muscles in the body are atonic and do not show movement. This dream paralysis called REM atonia is one of the most elegant neurological safety systems you have, and the machinery that makes this phenomenon possible lies in the brainstem. At the top of this machinery is a gray matter region called the sublaterodorsal nucleus, or SLD. An easy way to think of the SLD is as the REM off switch for your muscles. During the start of REM sleep, neurons in the SLD become active and they send signals down to the medulla, particularly to the ventromedial medulla and the gigantocellular reticular nucleus. These medullary neurons release GABA and glycine, which are two inhibitory neurotransmitters that travel all the way down the spinal cord, and they will essentially silence the motor neurons that normally activate your muscles. These spinal motor neurons become hyperpolarized, meaning their membranes are pushed so far away from the firing threshold that even strong motor commands from the cortex cannot activate them. As a result, your dreams will stay safely in your head. So the question lies, what goes wrong in RBD? And to address this question, I'm going to be passing it on to my respected colleague to help guide you through this.
Hello everyone, in this part of the video, I'm going to try and help answer the question, what goes wrong in RBD? And hopefully at the end of this section, you will have a clear answer to this question. RBD occurs when the neural circuits that generate REM atonia, primarily the SLD and the medullary inhibitory pathways, begin to fail. So the SLD might begin to send a weaker signal, or the medullary inhibitory neurons may degenerate and the pathways carrying GABA and glycine may lose all their strength, as you can see on the slides. All these factors together contribute to RBD occurring in some way or another. When this inhibitory system breaks down, the spinal motor neurons are no longer fully suppressed. The cortex will begin to send dream-generated motor commands, and this time the motor neurons will actually respond. The result of this is dream enactment behaviors, like kicking, punching, shouting, running, or even getting out of your bed entirely. Imagine it like this. Imagine that the dam that blocks your motor commands from being acted out is broken, and now all your dreams it will become a reality in a sense, because you will actually start acting out your dreams while you are sleeping. There is something especially fascinating about RBD compared to sleep paralysis. In sleep paralysis, the REM atonia system stays on too long. In RBD, on the other hand, the REM atonia system switches off too early, or it fails to activate at all. But here is the most important and slightly unsettling part of all this, and that is that the brainstem nuclei involved in REM atonia are some of the first regions affected in certain neurodegenerative diseases, particularly the alpha-synuclein disorders. This includes diseases like Parkinson's disease, Lewy body dementia, or multiple system atrophy. In many people, RBD appears years or even decades before movement symptoms like tremors, stiffness, or slowed walking occurs. The SLD, medulla, and nearby structures in the pontine tegmentum seem especially vulnerable to early alpha-synuclein accumulation, which damages inhibitory neurons long before the areas controlling voluntary movement are affected. What this means is that RBD is not just a sleep problem, it is often a neuroanatomical biomarker of early brainstem pathology. Now, I hope you've gained a great understanding of how RBD works and what goes wrong with it. But let's zoom back out to the experience itself. And to help you visualize and understand this experience, I'm going to turn this over to my esteemed colleague.
During a RBD episode, the sleeper is still in REM sleep. The cortex is actively generating dreams, and all regular REM activities are still happening. But the spinal motor neurons, which normally inhibit motor functions, are no longer active. This results in coordinated, purposeful actions that reflect the dream's storyline, because the brain is still sending real motor commands during REM. This is very different from disorders like sleepwalking, which occur in non-REM sleep and involve clumsy, automatic movements. Interestingly, RBD episodes usually happen in the second half of the night, when REM sleep becomes longer and more frequent. If a partner reports screaming, punching, or falling out of bed, RBD becomes a major clinical consideration. When you look at the neuroanatomy behind RBD, it becomes clear that even the violent or chaotic movements we see during sleep come from tiny groups of brainstem neurons trying to balance excitation and inhibition. RBD is not just dreaming wildly, and it's not a psychological disorder. It is a precise neuroanatomical failure of the REM atonia system, often reflecting early changes in the pons and the medulla. And while it can be frightening or dangerous, it is also one of the clearest windows into how brain orchestrates sleep and how sleep can reveal earliest signs of neurodegenerative disease long before daytime symptoms appear. Thank you so much for listening.